In this video, we're going to find an x value such that sine x plus sine of x plus 1 equals 1. So we're going to keep sine x the same. Sine of x plus 1 we're going to write as the angle sum identity for sine. So that would be sine x cosine 1 plus cosine x sine 1. And this extends out here. That's equal to 1, the right-hand side. So let's factor out a sine x. So we get, take out sine x, you get 1 plus cosine 1 times sine x. Then we're going to write the sine 1 term in parentheses times cosine x equals 1. Where this will be our a term and this will be our b term. So this is in the form a sine x plus b cosine x equals 1. So let's just come up with that identity, how to simplify this, simplify the right-hand side. So a sine x plus b cosine x can be written as r times sine of x plus an angle. Let's call it phi. Okay, so now that's basically the same thing. We're going to expand sine x plus phi, so that would be sine x cosine phi plus cosine x sine phi, right? So now this will be, let's write the sine x in the back, so this will be r cosine phi times sine x plus r sine phi times cosine x, where the cosine's in the back. So now we have that this is equal to a, and the other term's equal to b, so this is equal to b. So that's the system of equations. We have r cosine phi equals a, and r sine phi equals b. So this is equation 1, this is equation 2. So let's do equation 2 divided by equation 1. So the r's will cancel. Sine phi over cosine phi is tangent phi, which is b over a, which means that phi is the inverse tangent of b over a. Okay, good. Now let's try to solve for r. So what is r? So if we square equation 1, we get r squared cosine squared phi plus r squared. Now let's add it with equation 2 squared, which is r squared sine squared phi equals a squared plus b squared, where a squared is the equation 1 squared and b squared is equation 2 squared. Now we can factor out r squared, leaving us with cosine squared phi plus sine squared phi equals a squared plus b squared. Cosine squared plus sine squared theta phi is 1, so we take the square root. So this will be r equals the square root of a squared plus b squared. So that's how we get these formulas. Okay, so we have, what do we have? We have 1 plus cosine x, so we have 1 plus cosine x, cosine 1 times sine x plus sine 1 times cosine x, right? Yeah, equals 1. So we're going to say the right-hand side, 1, is equal to, now let's combine all of this into r, which is the square root of 1 plus cosine 1 quantity squared. So this will be our a value, and this will be our b value, plus sine squared 1. So now we have sine of x plus phi, which is x plus phi, which is the inverse tangent of, I guess we can just leave it as phi, and then we'll just say what phi equals, where phi equals the inverse tangent of b over a, which is sine 1, right, b over a from this. A is 1 plus cosine 1. Okay. So what is in the inside of this parentheses, or in the square root? So this will be 1 plus 2 cosine 1 plus cosine squared 1 plus sine squared 1. Cosine squared plus sine squared 1 is 1. So this will be 1 plus 1 is 2 plus 2 cosine 1 in the square root. So now let's divide by that. So we're going to be left with sine x plus phi equals 1 over the square root of 2 plus 2 cosine 1. Okay, nice. So now for simplicity, we'll just take the inverse sine on both sides. I know there's more values it could be, but we're just going to do it for this video. So we're going to take the inverse sine of 1 over the square root of 2 plus 2 cosine 1. And if you can simplify this, leave your suggestion in the comments. Okay, so we have x plus phi equals inverse sine of 1 over the square root of 2 plus 2 cosine 1. Now, to get x, obviously, we subtract by phi, leaving us with x equals inverse sine of 1 over the square root of 2 plus 2 cosine of 1, subtract by phi, and phi is equal to this value right here. Inverse tangent of sine 1 over, so we have inverse tangent of sine 1 over 1 plus cosine of 1. And that is the x value that I get. And I checked in Wolfram Alpha, and this x value works. And that is the end of the video. Hope you liked it.